a function cannot return a reference to any value created inside its body, or return a reference to an owned parameter, because either one of those situations would create a dangling reference. Let me show you. Let's begin by defining a function called create. And in the body of this function, I can declare an age variable set to an arbitrary value like 100. Now, returning age by itself is totally fine. So here I can specify age and specify a return value of an I32. So a function is welcome to return a value to the caller. But let's now try returning a reference to age. So I'll add my borrow operator right here and add the updated type right here to be a reference to an I32, and notice that this fails. This is invalid code because it creates a dangling reference. This is very similar to the nested scope example in the previous lesson. This function you can think of as its own independent execution environment with its own scope created by the curly braces. So the lifetime of this reference that we are returning is guaranteed to exceed the lifetime of the age referent. The age referent, or equivalently the age owner, will reach the end of the function scope, and it will clear the value of 100 from memory at the end of the create function's execution. So any reference that we return, any address to 100 that we return, will be invalid because 100 will be cleared from memory by the time this reference returns to whatever function called it. And this is true for a reference of any data type. So it doesn't matter if this was an integer or a string, a tuple, a vector, etc. It doesn't matter if the data is stored on the stack or the heap. The original value will no longer be at its memory address when the function ends, and therefore we are attempting to return an address to something that will no longer exist. This will always be a dangling reference, and the borrow checker will prohibit it. The exact same principles are going to apply to a function parameter. When a function parameter takes ownership over a value, the function cannot return a reference to that parameter because a reference to an owned parameter represents a dangling reference. The parameter will go out of scope and it will clear its value's memory as the owner at the end of the function. And that will guarantee that the return reference is a dangling one. So let's say I replace this function with a new one called createSlice. And this one will accept a vector of integers. Let me call my parameter items, and let me declare its type as being a vector of I32s. And here I can specify my return value in a couple different ways. I'm going to go with a slice, so I will say a reference to some array or collection of I32 values. Now, items, the parameter, is very similar to a variable declared in the body of the function. Items is going to take ownership over the vector that is passed in. Then, when items reaches the end of the function scope, it will deallocate the vector. Another alternative way that we can say this is that the lifetime of the items parameter will end at the end of this block, at the end of the scope. But if we try to return a reference, say back to main, and that reference is guaranteed to point to memory that is no longer valid. So for example, if I try to return simply a reference to my complete items vector, notice we have an error here. Cannot return reference to function parameter items because it returns a reference to data owned by the current function. That's not even the best message because the issue is not that the data is owned by the current function, but that the data will no longer exist after the current function. Similarly, if I try to return a slice, like so, a slice is still fundamentally a reference. It's just a segment of the original memory that we are providing a reference to. It's like a partial address to like a single bedroom in the house. We get the exact same issue, and we would get the exact same issue if we tried to return even a single element, or more specifically, a reference to a single element, because any type of reference, anything involving the borrow operator, is trying to return an address from this function to some data, that being represented by items, that will no longer exist because the item's parameter will go out of scope, or equivalently, because the item's lifetime will end right here, and the lifetime of the returned reference is trying to exceed the lifetime of the referent. If we were to take this return value in the body of main, if I invoke create slice right here, let's not even bother passing in any value, then this reference would be a dangling one, because this lifetime is trying to now continue on in main, but the lifetime of the referent from which it got its data, that lifetime is over. That referent's lifetime is over. Now in this example, the vector does not implement the copy trait, but the same rules will apply even if the parameter does implement the copy trait. So just to give you a really simple example, let's write one more function. Let's call this one create number reference. This time around, I will define a number parameter set to an I32. An I32 implements the copy trait. And here I will try to return a reference to an I32. And here I'll simply return a reference to number. This is invalid code for the exact same reason. So the only difference here is whenever we invoke create number reference and we pass in a value of a number, because the I32 implements the copy trait, Rust will create a full copy of the value that the caller passes in for the sake of this function invocation. So here, for example, if I invoke create number reference and pass in 10, we're going to create a copy of 10 to go into here. But that copy of 10 will still be deallocated at the end of the function invocation. Its lifetime will end, so the problem remains fundamentally the same. We are trying to return a dangling reference. We are trying to return a reference whose lifetime will exceed the boundaries of the lifetime of the value that it is referring to, that it is borrowing. So regardless of this type here, this is invalid. So to summarize, functions cannot return a reference to any owned value, whether it be created in the body of the function or whether it be taken from the parameter of the function, which similarly will have ownership over a value. Now, a function is welcome to return the owned value to avoid this problem. So instead of returning a reference, you can return a number. You can return a vector. You can return a piece of data that you create in here or that you receive from a parameter. But you cannot return a reference to an owned piece of data, whether that be a variable or a parameter, for the exact same reason, because it would be a dangling reference whose lifetime would attempt to exceed the lifetime of the data being borrowed. And the borrow checker will not be happy about that.